get started, just feel free to keep coming on in. Hi, thanks for joining us, everyone. Really appreciate your time today. Hey. Special welcome. Cool, so really appreciate your time. I know it's getting sort of later on in the day, and there's been a lot of sessions already, and there's some fabulous sessions on at the same time as us. So thank you guys for coming to this room and seeing our talk today. It's great to be here with you. So we're going to be talking today about platform engineering, covering things like IDPs, Backstage, Red Hat Developer Hub, and all that fun stuff. Just to introduce us, if you've not met us before, my name is Grace Jansen. I work at IBM. Well, it was Grace Jansen. You might say Grace Robinson, also up here. It's a little bit confusing. I just got married, so I'm under like 2 aliases right now. It's quite fun. It's like a spy world. But yeah, Grace Jansen is now my stage name, I guess, if you could call it that. So yeah, you might see me around. But I work at IBM in the UK, mostly on Java, in the Java world, especially cloud native. I've been a dev advocate now for about 7 years, but before that, I did a biology degree, because my knowledge of fish has come in really handy. So if anyone wants to chat about that later, I'll be hanging around afterwards. And I'm here today with Maarten.
Yeah, I'm Maarten Vandeperre. I'm a specialist solution architect at Red Hat, with specializations in application development and AI. I think our journey started last year in Vox Days Luxembourg, where we started discussing about Backstage and the challenges we had with it, resulting in working together on the workshop, resulting in, hey, why shouldn't we submit for the Vox Days?
Yeah.
And now we're here.
Yeah.
And Grace, I think you will tell something about the cloud first, right?
Absolutely. OK, so the first thing we're going to do is just set the scene a little bit. Hopefully you enjoy my Disney references. I love Disney, so homework if you haven't seen it, Toy Story. But it's kind of like, why are we trying to build cloud-native applications that are effective? And it's why it's a lot of effort to move to the cloud. Sometimes we get a lot of pain with it. Are we really gaining enough to go through that pain and to want to bother? And I think it's this feeling that we get as engineers, this, ooh, the cloud. We get excited about the cloud because the cloud brings with it lots of benefits like flexibility, portability, scalability, being able to hopefully be cost effective, and have the latest and greatest innovations sort of at our fingertips to be able to use. So the cloud gives us all of this, and we want to be able to effectively build our applications and have an effective pipeline when building for the cloud. But it doesn't always feel like this. It usually feels a bit more like this. It can be frustrating, it can be draining, we hit problem after bug after problem, and trying to decode all of that and figure out how the best way to build for the cloud can actually be kind of a challenge and just really frustrating, really. So what we're going to do today is try and figure out, can we make that journey easier? Can we make that process easier by introducing the concepts of platform engineering, looking at some of the acronyms, because we're in tech, we love acronyms. I swear, joining tech was like speaking Latin. Man, there's just acronyms all over the place, and I had no idea what they meant. So we will explain them as we go through this. But we're going to take a look at, how did we get to this stage? What are the challenges that we're facing as developers? We're going to take a look at those struggles, and then we're going to take a look at how platform engineering can help solve some of those issues, taking a look at internal developer platforms, internal developer portals, the benefits they can give us, and some of the tools to get there. Now, a lot of us will be developers in the room, hopefully, given you're at a developer conference. And so don't panic. This isn't all theory. We have a live demo, if the demo gods love us today. If not, we have a video backup. So it's all good. But we're going to be doing that later in the presentation, just to show you how we can actually use those tools in reality. And then we're going to finish up with some summary and resources. As if we haven't flooded you with enough information already, you'll have a flood more resources you can go and take a look at after if you're interested. OK, so starting off with what happened. How did we get to this stage? What are some of the challenges and struggles that we're facing as developers? So it kind of not stems from, but this sort of shift left that's been happening, this increasing cognitive load on developers, this movement that we've had from sort of having separate dev and ops departments or teams, going to now suddenly we have to not only build it, create the application, but now we're running, not away hopefully, but running it. And it means that we have this increasing list of responsibilities and tasks and areas that we as a development team have to be responsible for. We've gone from just having dev and ops to DevOps, and then that got expanded to FinOps, MLOps, GitOps, DataOps, and then suddenly that expanded and it became a combination of all the above. And suddenly we have Biz, Dev, Sec, Fin, MLOps. I don't even know what that is. So we have this huge expanding list of responsibilities, and it's not just app development we're responsible for now. We have to think about a load of different stuff when it comes to actually just doing application development for the cloud. And what does that mean on us as developers? We can see on the, I think it's your left here, yeah, on the left-hand side, you've got a list of responsibilities there of kind of what's involved in application delivery for the cloud. Anything in light blue is the dev responsibilities. Anything in a darker blue was more traditionally sort of an ops responsibility. And we had happy dev, not so happy ops, because there was a lot involved there. And we've kind of just gone to a more miserable world, unfortunately. So we've moved across, and now we've got even more happening in the development team. They've got more responsibilities, more tasks. But ops are kind of confused as to what they're responsible for, that development aren't responsible for. There's a lot of sort of like blending between the two and overlap between the two. And now we've got a sad dev and a confused and angry ops. And it's really just not an ideal situation. So what we really want to be able to do is make this better by having clear clarity between the distinctions of what should dev be responsible for, what should ops be responsible for, and can we make it easier by maybe having something in the middle that can help automate some of these decisions and sort of, I guess, processes along the way. On top of the growing responsibility of tools and responsibilities, there's also too much choice when it comes to the tools we can choose to deal with those tasks. So I've got a fun game for you all here. I've hidden Wally, or Waldo, in the diagram. How long can it take for someone to spot him? Shout if you see him or raise your hand. Yeah? Oh, that was pretty quick. That was pretty good going. Most other conferences, it takes them a lot longer, so maybe I should hide him further down. But you can see here, this is the cloud-native grocery store, as I like to call it. It is essentially the landscape from CNCF. I call it the grocery store because it's where we go to shop for all the tools we need for our application. But it's massive. This list is insane. Just trying to navigate this map is hard in itself. So, it really highlights the problem that there is a hell of a lot of choice here, and we're trying to discover and figure out which options are best for our application and why. Trying to make the best choices possible. There's a lot of choice out there, and if you didn't spot Wally, he's there, if anyone was frustrated and not quite getting there. So these are some of the developer struggles. They're not all of them. We've also got things like, as we move towards the cloud, we're having to get used to things like CI/CD tooling. I really enjoyed this diagram because it's exactly how I felt going into sort of the cloud-native infrastructure. You're learning containers, then you discover Docker and you start getting familiar with Docker, and then suddenly you understand Kubernetes, and you're like, yeah, like I understand the cloud, and then suddenly you realize there's a hell of a lot more to cloud-native than I realized. And you kind of realize this huge, steep learning curve that you're going to have to go on that involves a lot of not just learning the theory, but also, as I said, understanding those options that are available to you. Maybe you're not using Docker and Kubernetes. Maybe you're using something like Podman or whatever it is. There's a hell of a lot of not just tools out there, but also open source standards to consider as well. And then on top of that, once you've created this CI/CD tooling pipeline, we have to observe it to understand what's going on. So that's a whole other layer we're adding on top as well. So really steep learning curve here. Not only that, but once we start getting into the use of containers, we've got the fact that containers offer fantastic portability and flexibility, being able to quickly spin them up and utilize them. But it also means we've got a lot of decisions to make here. Which tools are we using? How are we configuring our environments? How do we build our applications? And it's really challenging, even when you have use of containers, to ensure that there is consistency among the sort of different variations in those containers and to stick to best practices. Things like operators can help, and things like cloud-native build packs can also help, but it can still be really challenging in this particular area. And then on top of that, security, which should obviously never be forgotten, and as good developers, we always remember security. But security and regulatory requirements, this area is constantly changing as we understand and get better acquainted with what we should be doing in our development practices to ensure that our applications remain not just compliant, but also secure. Just recent events like Log4Shell, Log4j, highlight the fact that this is still an area that we're trying to improve in and get better at and understand better. So things like introducing S-bombs. Do we know what's in our application? Some of the talks today earlier were mentioning S-bombs, so you might have gone to those, like Andre's talk earlier. I think it was the session before us, just next door. He was talking about S-bombs, the fact that we are able to get the software bill of materials so we can understand what's within our application, understanding what vulnerabilities we might have that we have to be aware of in our apps, ensuring we have a trusted supply chain. So all of this, again, is also considerations that we as developers have to be aware of and implement in our own processes. And that's not all, as if the list goes on. You're likely, as a developer, not only dealing with these struggles of the CI/CD tooling, the steep learning curve, the fact that you've got container management now, we've got to think about security, we've got this growing list of responsibilities. On top of that, you're likely drowning in scripts, for example, that are having to be maintained. You are likely trying to reach a level of automation that you may not be able to get to. You're likely to have key person dependencies, depending on how your organization works, and in terms of things like being able to create new environments or being able to access tools. Creating a new environment can be a really long process, especially if you have that key person dependency, and if they're on vacation, not ideal. So there are lots of different other developer struggles that are more sort of organizational because of the way that we're now having to develop for the cloud. So all in all, if you're dramatic, like me, feels a bit like this. I feel like this quite regularly when it comes to cloud-native development. It's frustrating, it's annoying, and this isn't just me saying this, okay? There are studies out there that support these feelings and the way that we're reacting to all of these challenges. In fact, there was a study done that shows that the top 3 causes of developer burnout is that increasing workload, pressure of digital transformation, and requirement to learn new skills. All of these feed into those challenges that I was talking about. In fact, Luca, who's a great advocate, he was like, come on, really, devs, do we want to be doing ops? And the majority said yes, which I was quite surprised at. But actually, when you combine the no and the swear word no, I'm not going to repeat that on the screen right now, but actually that comes out as more just, I think, or yeah, just 0.3 more than the yeses. So actually, developers don't really want to be bogged down with all of this extra need to think about the ops side of things. They want that automation. They want ease of use when it comes to developing cloud-native applications. So, having set the scene in such a positive way, how do we now go about overcoming these challenges? And hopefully Maarten's going to tell us a bit about that.
Yeah, surprisingly, if you saw the title of the talk, platform engineering is here to help. So what is platform engineering? Yeah, it's a discipline of designing platforms, not rocket science either, but what do we call platforms? It's mainly an abstraction that will abstract away the necessities you have to maintain the application lifecycle. Often it's put in battle with DevOps, but in the end, it's not really competition of each other, because platform engineers will make use of DevOps principles to develop the platforms. Then we come to the platform engineering recipe. Before you want to start with building a platform, you will need to decide upon the capabilities it needs to have. For example, which version control system will you have? Where do you want the applications to land? Is it on VMs? Is it on orchestration system like Kubernetes? What will you do with observability? What will you do with security? Always a concern. What will you do with runtimes and frameworks? So whenever you've made up your mind about the capabilities of the platform, you will need to bake it. What do we mean with it? For every capability that you want to add to the platform, you have, with a little bit of exaggeration, a dozen of components that you can choose from. Let us only think about CI, for example. There you have Jenkins, Tekton, GitLab, GitHub, good old Bamboo builds, and so on. It's there for all the capabilities that you want to add. So what does it look like then? You have the baking process of your platform, the components out of which platform engineers can take the best fit for your organization. They integrate it together into a developer platform, but that still has some issues. It has still a dozen of interfaces for developers to work with. You have to go to GitHub. You have to go to the page of every repository. You have a dozen of documentation pages that you have to go to. It's what we call often a bookmark hell. To avoid this, platform engineering teams can put a developer portal on top of this. to make life of the developer more easy. So the internal developer platform, it's the centralized collection of tools, services, components that enables rapid software development. So it will take care of the coding itself through developer environments, CI, CD tooling, security tooling, observability, and monitoring. And it will abstract away the complexities that go along with the infrastructure and with application configurations. What is then the portal? The portal is the single view on this platform. The single pane of glass, single pair of glasses. So one interface to connect to all the underlying components of your platform. So be aware, the platform is the environment, the ecosystem. The portal is a single view on top of it.
It's also probably important to note that in this presentation, we are using the acronym IDP for that internal developer platform. You might see other articles online, confusingly, that call internal developer portals an IDP. So just, if you're looking at articles and blogs and references, just double check. If they're using that acronym IDP, just double check, is it a portal, platform, what are they referring to? Because it can be a little bit confusing sometimes. But in this presentation, just to be clear, we're talking about platforms.
And to make it more fun, identity providers can be IDPs as well.
Yep, just to throw that in the mix.
But yet another tool. But Grace, I think they bring some benefits, right?
Yes, absolutely. Okay, so it's important to take a look at, why are we bothering to do all this? What is this actually going to bring to the table? So in terms of the organizational impact, smiley faces, which is great to see. So it's interesting to note here, we now have 3 teams. So we've got dev, platform engineering, and ops. Now, Maarten, what about the platform engineering team? Is that all new hires?
I don't think it needs to be. I think it will bring added value to your company if it is just a team. Some dev-oriented people, some infra-oriented people together. And you can even choose then the more junior people in the silos of dev and ops, more senior people, people that want to do something from the other silo as well, can be brought together into a platform engineering team.
Great. So it doesn't necessarily mean you have to go out and advertise, I need platform engineers. It's just a way of reorganizing your current organizational structure. So just to bear that in mind, that this should be possible for any organization depending on the size. And we'll get onto that later. So here, now we have this very obvious and clear split between those responsibilities that we saw before. Now developers can focus on writing applications and doing what they do best, bringing innovation and advancements into the behavior within those applications. We've got the platform engineering team, and that's where we're really focusing on building out those sort of golden pathways. So those pre-configured, pre-structured pathways where they've already chosen the tools you're going to be utilizing, the CI/CD pipelines, being able to show you and automate that application build and deploy process, as well as making choices already about things like the Java you're using, the runtime, the operating system. And then we've got the ops side of things. Now they're really clear on what they're in charge of, what they should be dealing with, looking at sort of virtualization, clustering, hardware, and the entitlement and billing. So happier people overall, hopefully, is the aim. But it's not just about the qualitative, there's also quantitative benefits as well. Now we put this slide in because we know that, as developers, we don't necessarily always care about the numbers, but the people above us usually do. So if you need any persuasion or your bosses need persuasion that platform engineering might be something you should consider, there's a great website here that I've linked to that has done specific studies showing those quantitative benefits, including things like wait times due to blocked environments being decreased, average deployment frequency going up, onboarding time for new developers getting reduced, and lead time as well. So there's a lot of quantitative stuff we can actually measure that also improves by utilizing the sort of practices and processes in platform engineering. Now, that's not to say that this is the be-all and end-all and everyone should go and do platform engineering. I'm not going to make that sweeping statement. Just like, when we originally had microservices and everyone was like, everyone should do microservices, and it wasn't always the best architecture for your application. It's important to consider the good and the bad when it comes to changing anything within your organization and your application. So we wanted to show here that actually, there are some really great things about platform engineering, like the possibility of having increased autonomy for your development teams, reducing time to market, and increased developer satisfaction. But there are also challenges involved. Things like user authentication, being able to build a scalable team, Because if you've got a huge organization and you've got like 5 people in your platform engineering team, that's a lot to put on that platform engineering team. So you have to make sure that you're able to have proper resources into that platform engineering team to actually make this workable. Building self-serving solutions can be challenging, and things like compliance with security regulations as well, especially if any applications need anything that might be specific or unique that can't be built into those golden paths. The bad, as I said, there is a strain on the platform engineering team, especially if you're in a small company. That's another thing to consider. We've gone from one end to the other here, so large to small. If you're in a small organization, it might not make sense for you to have a platform engineering team if you are small enough. So really, it's about weighing up these pros and cons and deciding, actually, is this something that can work for your organization? So now that we've taken a look at what platform engineering is, what an IDP is, what an internal developer portal is as well, making sure we clarify that there's a separation, we've also taken a look at the benefits and how it can help us with some of those challenges that we're facing. But what we really want to know as developers is, how the hell do I actually do this in practice? So this is where we're going to take a look at tools that can help you with this.
So first thing on the platform, side, you always find reference architectures, for example, from Humanitech and McKinsey here, often grouped in developer control plane, security, integration, monitoring. You as well can have a look at the IDP landscape. You can as well have a look at the Where's Waldo image that you had in the beginning of the presentation. This is one from platformengineering.org. Then in the portal world, I think the biggest player at the moment is Backstage. It's an CNCF incubating project, and it's donated by Spotify.
It would actually be interesting. Has anyone heard of Backstage before? Well, there are quite a few hands. Great, perfect. What about Red Hat Developer Hub? We're about to go on to that. OK, less hands. Great, perfect.
Who already integrated something within Backstage?
Oh, OK, cool.
Yeah, so it's an open platform for building developer portals, and it can be customized with plugins. But the biggest disadvantage of Backstage is that you really need to touch the source code in order to get integrations in to get it up and running then. So what does Red Hat do? First of all, Red Hat is doing everything open source, so this is not our code base. It's downstream from Backstage. We introduced Developer Hub. It's enterprise grade, so hardened for security and stability. And it introduces the concept of dynamic plugins. So you can enable plugins next to Backstage without having to touch the source code base. So all through YAML definitions, as you will see in a second. It is built on Janus as a midstream project, but we just had to create this because we had to refactor too much on Backstage to get the dynamic plugins in. Nowadays, Backstage is taking over the effort we put in Janus, so Janus is getting out. Developer Hub will be the downstream of Backstage directly. But why going to slideware if we can show this, hopefully, in a demo?
The demo gods here.
So everybody, fingers crossed now. So for the demo, we will build a platform, and it will consist of Tecton, GitLab, Jenkins for the CI parts, Quay for the image registry, DevSpaces as an integrated developer environment here, and it runs on OpenShift, which, if you're not familiar with it, you can see as a Kubernetes engine. And then we have the developer portal driven by Developer Hub Backstage. So within GitLab, we don't have any game repositories at the moment. So to initiate this, we go to Developer Hub, which is this one. Backstage looks the same because it's the upstream project. And we'll create a software template. A software template, you can see it as a blueprint for an application that you can initiate bootstrap through this functionality. We already have some blueprints at your disposal, but as you can see, we don't have an Open Liberty one yet. So let's see how to create these software templates. And to be honest, it's fairly easy. First thing you need to do is you need to create a template configuration YAML file, which will consist of parameters, which will be later on be filled in through a form, and then some steps that needs to be executed during bootstrapping, during the initiation phase. Next to the template, we have a skeleton, which is the default project, the abstract project, the primer, depending on how you name it within your company. with the source code, build tools like, for example, Gradle inside, and one particular file, the catalog info, which just is containing the name of the repository, coming from the parameters that you fill in, and, for example, other parameters that you define. These parameters can be used, for example, in package names and class files as well, so that you directly have the package names containing the name of the new application that you're bootstrapping. We have a more extended template.yaml file as well for Open Liberty. So let's take this definition and put it into Developer Hub. Only thing you need to do is point to the YAML definition and import it. So now we can create an Open Liberty one. We select this blueprint. You select who is the repo owner. For example, it will be me, or it will be the team where I'm working for. You can select on which cluster it will be deployed because it will connect to Kubernetes behind the scenes. You can choose some parameters for the CI methods and so on. But for the demo, we will go for a game that we introduce. It's a game with, it's a car racing game. For the ones that attended the presentation of Kevin Dubois, this is the source code behind it. So we select the cluster on which it will be deployed. We will select an image registry, which will be Quay for now. And we select the version control system. For us, it will be GitLab, where the repositories can be put. We review it, and we create it. So this will take just a couple of seconds, normally.
So the nice thing about these is that you can have that flexibility as we showed. So if one team needed to use, in this case, this application is running on Quarkus, they needed to use Quarkus, for example, and another team needed Open Liberty, which is another open, in fact, I should ask, is anyone, I assume people have heard of Quarkus. Yeah, there's like nods around the room. Has anyone heard of Open Liberty? A couple of nods. If you've not, you can head to openliberty.io and check it out. It's on my t-shirt, as if it wasn't obvious enough. It's another open source runtime, just like Quarkus. But it's that fact that you can have that flexibility to be able to swap and change what's needed for different teams. You can create different golden paths, for example, or depending on what your application needs or your organization needs. So we could swap out Quay, for example, for another image registry, or we could use something else in there, like Keycloak or whatever. You can have that flexibility with making different golden paths depending on what different departments or different teams need within your organization.
Yeah, and it isn't even bound to Java as well.
Yeah.
For example, with data science popping up now as well, it can be Python, but it can be .NET, it can be Scala. It's not bound to any programming language.
Yep.
So by now, Developer Hub initiated the repositories. So let's refresh our GitLab projects. And you see that you have 2 repositories now, 2 because we made a decision to split the code base from the CD, the GitOps artifacts. So in order to initiate the CI pipeline, you could change something, but and for this I will use developers, dev spaces, which is an integrated IDE that can run on a Kubernetes system. So let me quickly open this and clone the repository that we've created. Yep, I trust the authors. And now it reloads because a new project is getting imported. Cool thing is, you can fairly easy start with coding if you're using dev spaces because nothing needs to be configured on your local machine. Behind the scenes, it's all running in Kubernetes, and it's giving you UI in the browser. Disadvantage, if you're not connected to the network, this will not work. So let's go to the configuration file and change a property over here. Let's commit this. Okay. And some Git actions needs to be configured. So it as well has a terminal, which is then connected to your Kubernetes cluster, so you don't need to configure as well connections to that Kubernetes cluster. Yeah, I will allow copy-paste. And I will need a username and a password. It's not that secure to do this in recording, but the environment will be stopped after this session anyway. Developers and securities, right? So now this is kicking in. What is this next? What is that next to the initiation of the repositories on GitHub or GitLab? Sorry, here it creates as well the component within the catalog. Catalog doesn't only contain software projects. It as well can contain group configurations, people being grouped in departments. For example, systems that you can see as the application platforms that you're building, resources as databases, Kafka topics. Here we go to the SSO of Kafka, in which you already see the dependencies within your organization. You can go as far as you want that you see, for example, the RHDH group is containing group 1, so team 1, for example. You can see which APIs are managed by these teams, which resources they have at their disposal, who's belonging to these teams, and so forth. But if you now go to the project itself, you can see the CI pipeline, which is now started to the change that it created. And what it will do, first of all, it will take the Git repository with the Git clone, it will package it, and it will start scanning the source code, building and signing the container image. Why signing as well? Yeah, because container images can be tampered with. So we sign it that the underlying system knows that it's really the image that it should be using. SBOM stuff, as already mentioned before, some other security checks with ACS, but not part of this presentation. And then we do a resync. It's just to let Argo CD know that there is a new version that can be deployed to the system. You as well have a topology view. That's, for example, viewing how the status on Kubernetes look like. You'll see that all deployments are still in red phase, so they're failing. Fairly easy to explain. Argo CD didn't finish yet, so there are no images yet to be deployed. So that's why all these deployments are in a red state. You can link to Jira, ServiceNow tickets in this view as well. You can list pull requests, merge requests, which can make it more efficient as well to review those. Because what happened in the past as well, when I had a pull request, I had to open Teams like 4 or 5 times to my colleagues, hey, can you please check the code review pull request? Now when you have to wait for your CI pipeline and you're working on the same project, in the same view, you now have the list of outstanding pull requests. You can see what Argo CD is doing, if everything is already synced, or why a version is not yet in production or on a staging environment. You can have a look, it's not yet there, but which images are getting published to your image registry. And you have API definitions here as well. These definitions are the APIs that are linked to your project. You as well have an API listing within Developer Hub, within Backstage, which can contain all the APIs within your organization or within a subset of your organization, depending on the API security. If you have a closer look at what's inside, there's an open API one, so you will be able to access the Swagger pages like you're used to execute it from within this environment if the user security is set up. Then you have documentation as well. So this is the README file or multiple README files that are listed to this project. And again, you can have an overview here with multiple documentation pages. It's important to note that if you have documentation over here, that you don't have to literally translate everything from Confluence, SharePoint, all these tools, to Developer Hub, to Backstage in the Markdown format. What I've seen at customers is what they often do, that they make a page for documentation, for example, for this application, and from within this document, this documentation page in Backstage, they link to, hey, best practices can be found on Confluence. how to work with this database, it's this SharePoint URL. It's all centralized, but it doesn't mean that all the documentation needs to be centralized as well. It's just one entry point to the documentation stack. Same thing for the learning paths. You can list all learning paths that you have internal in your organization, GitHub pages, tutorials, and for example as well links to Udemy, Coursera, and all these training portals. You can work with Tech Radar as well. Say for example Java 11. Still some companies are using this version. You can say, yeah, we still allow it in our company, but we put it in a deprecated phase. We're already looking at Java 21. Maybe evaluating Kotlin, for example. You can visualize this in your Tech Radar. Whenever developers then are saying, yeah, I would like to use this tool, this runtime, this components, you can already see that the organization, for example, the architects, don't know who's responsible within your organization, is looking into it, and you can see in which phase it belongs. And then we have the orchestrator, which is one of the newest plugins we have now, and it's to do some workflows. For example, we have a Hello World workflow. It's the greeting one. If it wants to load.
I feel like we got pretty far before the demo gods could.
Yeah, I was thinking the same thing.
Yeah. So as you can see from what we've shown, oh, sorry, I'll let you finish that bit.
Oh, no, go ahead.
As you can see from what we've shown, the fact that we can introduce those golden pathways and have that sort of fully automated CI/CD pipeline, linking it in not only to sort of the build process and the deployment process, but also into those additional parts like documentation, like API descriptions, being able to onboard new developers faster by getting them up to speed on our applications quicker and allowing them to be able to debug faster with that documentation. So really, it's a really quick and efficient way to hopefully enable greater productivity, greater developer satisfaction, and take away some of those challenges and struggles and stresses that we were facing before.
So yeah, we have workflow, again, as everything on Kubernetes is YAML, this is as well, but with a visualized image here. So we have to choose a language, then we have two greetings, one in English, one in Spanish, and it will greet the person. If we run it over here and we directly go to Spanish, and we run it, then I hope if there are Spanish people in the room that we don't make a mistake in the translation, but this should be then the greeting in Spanish. This is a simple Hello World form, but you can use this, for example, to trigger automations, Ansible playbooks, all these things from within an automated workflow already starting from Developer Hub Backstage. So this was what I could show for Backstage, but Grace, it's not the only one that's there, right?
Yeah. So just to show that there's not one solution for this, there are lots of solutions out there. If you're interested in a different form of creating sort of an IDP, Kratix is another technology you can use. It's Kubernetes-based. It's based on forming contracts between the development teams to be able to create sort of an IDP and those golden paths. Kratix is quite an interesting one to check out. But there are also other proprietary options as well. And there's a list that you can find. I've put the link at the bottom here. We'll be sharing our slides. If you want to check them out, then please do. But I have tried to also put some of the logos to make it easier to check them out as well on Google if you're interested in those. So yeah, other options out there. You don't have to use Red Hat or Backstage. You can check out what's best for your application. So hopefully what we've shown you is that it's a complicated world out there, but hopefully IDPs can guide you, going back to that Pirates of the Caribbean gif right at the start where we were running away. Hopefully now we're sailing towards success with IDPs. So just to summarize our session today for you. So cognitive load and the demands on developers are ever increasing and are creating a huge amount of stress, lack of productivity, and are not really the most effective way necessarily that we could build applications as we move towards cloud native. But the nice thing is that there are tools and processes out there that can help us with this. So developers can be helped through things like platform engineering, IDPs, which again, remember, it's that internal developer platform here, but also internal developer portals as well. Golden and paved paths, so really figuring out what are those paved paths for your organization, and there might be multiple paved paths, as I mentioned, depending on whether you've got different teams with differing needs and what the tools would be for those differing needs and requirements. As I said, what this looks like is going to be completely different depending on your organization. And that's the beauty that we've been talking about here.
Indeed.
Is the fact that you have so much flexibility within not just how you build your IDP, but which tools and processes are involved in that, how you set up your portal, which platform you're building it on. So it is really a unique solution depending on your organization and application. But you can use tools and technologies that are already available out there, and there are lots of open source options as well. So as I mentioned earlier, homework, as if we haven't given enough links throughout this presentation already. So if you want some examples of companies that have already gone out and documented the successes they've had with creating IDPs and following platform engineering principles, then we've got some examples here. I tried to pick a range of different sizes, so hopefully there's an organization in there that best sort of matches your organization, so you can kind of compare what you might be able to gain from it. So we've got sort of huge organizations like Netflix, which there's not many who rival Netflix, but we've also got some kind of smaller organizations in that list as well. If you wanted some more information on platform engineering, there are lots of useful communities and resources for this. There's a really great weekly newsletter that you can sign up to. There's also a Slack channel with a whole community already in there. There's PlatformCon. It's actually really fun to watch the PlatformCon recordings because they're only about 20 minutes long. So it's really quick to be able to actually get quite up to date. And they put all of their recordings on YouTube. So do go and Google for that, and they've got a whole playlist from multiple years of, I think there's been about 3 years of conferences there, so quite a lot of material in that as well. And then there's also some additional links here for blogs. There's one that Maarten's written in there as well. So basically kind of recapping what we've talked about today, the fact that there's a difference between portals and platforms, the benefits you can gain, what tools you can use, and why IDPs matter. So with that, we're going to say thank you so much for coming to our presentation today. Hopefully, it's been useful and you've learned something, even if it's, platform engineering isn't for you. That's as valuable as if it is. If you have any questions afterwards, we'd be happy to take them. But given we've got 1 minute 36 left in this presentation, I'm going to say come down to the front so that we don't keep people from the coffee break that's importantly next after us. So thank you very much for your time. Feel free to reach out on social media if you don't want to come up to the front today. Thank you, guys.
Thank you.